Australia is a country rich in culture, heritage, and diversity, but there's still work to be done to ensure true equity for all. In this project, we take on a real-world social challenge named Closing the Gap. It is national initiative to improve the lives of uh, Aboriginal and Torres Strait Islanders peoples. As a part of our Java Studio Milestone 1, our team set out to design a web-based application that helps track progress on key social economic outcomes for health and education to life expectancy using real census data from 2016 and 2021. In this video, I will walk you through our initial ideation process, how we define our goals, who we design for, the wireframes created, and the database model we envision to power meaningful insights. Okay, so let's take the first part of our video on our task.
Right. Hello, lecturer. My name is Bernard Huang, and I'm in charge of level one subset of A and B. So this is the persona of my level. So Olivia Carr is a health policy advisor for the state government, and she needs a way to access to the population of access to the total population of Australian state and territory for 2026, 2016, and 2021. Uh, as that's an essential hub for all 17 socio-economic outcomes. So let's go to the homepage and see how we can help her. So in the homepage, we have a nice design to make user have a more student vibe to it. Here we can see the all 17 socio-economic outcome is displayed nicely, and since the assignment only focus on two outcomes, we also have a tagline here to so our user can know what this website is focused on. And the last thing is a table. So this table display, calculate and display the total population of Australian states during 2016 and 2021 for users who needed it. So let's go to the Our Mission page. The Our Mission page have four things. Our mission, how can we help our customer and our team members. Our mission, we describe how we're gonna help, how we can help the researcher, and in the how we explicitly points out what this is what can help. Here we see our customer. Basically, this is persona that we push from our database on here. We use the database to store the persona since it's easier to edit it if something happened. And here you can also see our team member here. Let's go to the entity relationship diagram. Since most of level one job is to display information, we don't have much connectivity between all the entities except for one. So here you can see the persona, the persona and social team member. That's on its own since they just serve the purpose of displaying information and don't have anything related to any other entities except for the population. See, the population entity need to extract information from integers by age and state territory to calculate both the population of Australian state and territory in 2016 and 2021. So it's connect to so it have to connect to the LGA. So up next is subset 2A.
So today we're gonna cover level 2 subtask A, which is health conditions and age demographic. So let's start by looking at our persona. His name is Tom, and he's a data journalist, specifically in health data. So he needs to find some data for his analysis and reporting, and he wants to quickly filter through all the health conditions by state, gender, and indigenous status to uncover meaningful insight into them. He also values the summary of data without downloading or parsing complex spreadsheets. So first, we see our website, and we're going to pick health demographic. It will show us a table, and it will let us enter in the things we need. So for example, we select New South Wales, male, stroke, and non-Indigenous. Oh, around the area of New South Wales, it will create an LGA, which are the areas within New South Wales. The gender we picked, which was male, the condition, status, this is the total population, and how much percentage does that population take up. So for example, in the Central Coast, around 246 non-Indigenous men had a stroke, which is only 0.10% of the New South Wales population. For another example, we pick Victoria. Let's do female, asthma, and Indigenous. As you can see, in the area of Latrobe, only 86 female with Indigenous background has asthma, which is only 0.05% of the population in Victoria. So how does this satisfy our LGA? Our persona, Tom, needs to quickly find our information. So in certain areas. So as you can see in this ERD here, first we enter in an LGA. This will send a message back to the LGA table right here, and it will send us the code. This LGA code will be sent here, will be analyzed, and it will open up a table containing the rest of the information. So for example, so this will help Tom out quite well because it quickly sorts through the category that Tom needed and immediately gives us data right here. So Tom can pick any category that's pickable, like Northern Territory, and just everything, and press view results. This might take a bit because it's loading in a lot of information. Make it go by a bit faster. Let's just put male cancer and Northern Territory. So as you can see around in Central Coast, which is usually New South Wales, which also counts in the Northern Territory, gives out all the information that Tom needs to make his report. So for example, if he wants information on Central Coast, he now knows that around 45,000 Indigenous men had cancer, which is 6.32% of the total population of New South Wales. So this satisfies his goal very quickly because it helps him filter out all the things he needs and also quickly find the information very quickly without him needing to do any summary work of his own.
Okay, so I will talk about the subtask to be of our web page. So first, let's look at the our persona. So this is our subtask to be persona, Amelia Cater. So this page is designed for user like Amelia Cater, a youth worker from Dubai, and she needs to present how many Indigenous students in New South Wales complete year 9 to year 12. So all closing the gap application aim to give her the information in a very friendly and easier to understand way. So she opened the school and non-school completion rate page, select New South Wales, tick year 9 equivalent, and click view result. And instantly she saw a clear table showing indigenous and non-indigenous completion stat. No calculation and download needed. She just need to take the screenshot of the data and put it in her slide. This saved her time and helped her explain local education trend to her Dubo community. So now let's take a look at the website. So this is our SubTAP website education rate, as you can see here. The layout is very clean, simple, but easy to understand. From here, you can select state or territory, for example, New South Wales. And now you can choose the education type, school or non-school. I choose school. So now you can select your preferred category, and now you can just click Vim results, and it will show up. Our website results show data that easy for user to read. For example, like we switch all the certain word from the database to clear word like indigenous year 3 equivalent. We also show the raw data as well as the percentage. Not only that, our website and this subtype can also, you can choose multiple category with results, and it will show multiple category as well. And not only that, this subtype also have the reset function. So when you're done, you can just reset and do it and have a fresh start. And for this page, the we are certified to Nielsen Heretic. Sorry. So for this page, 2 Nielsen Heretic is applied. First is the visibility of system starter. The table appear immediately when a filter is applied, confirming user action and visual feedback. And clear bottom like Vim results and reset, user flow without confusion. And also we follow the match between system and real world design in the neural heuristic. Term like years 12 equivalent and bachelor degree reflect how Australians naturally talk about education. We try to avoid all the technical terms that user may find difficult to understand. And so finally, let's talk about the ERD of subtype 2B. So from the backend perspective, this subtype draw from school education, non-school education, LGA, and state territory table. And each record link on LGA in years to indigenous data, sex, category, and count. As you can see here in the back end of subtype 2B. And each SQL join and filter computer total and percentage in real time depend on what user selected. And that would be the end for my presentation on subtype 2B. Now let's move to subtype 3A of my teammate.
So moving on to the next subtask, I'm going to talk about a few things about this subtask persona, which is David Moore. He's a 42 years of indigenous policies based in Canberra. David worked for a national government department where he tracked progress on the closing the gap targets. So David's biggest need is speed and clarity. He wants to quickly see where's the gap between indigenous and non-indigenous Australians are closing or widening, especially between in the 2016 and 2021 census data. He also faced common challenges such as government data portal are slow, overloaded with filters, and lack of easy to read changes by LGA. So despite this, David is skilled. He uses dashboards and spreadsheets and reviews policy data regularly. What he needs is a simple, responsive tool that lets him filter by sex, educational levels, and so on in order to produce clean outputs for format reporting. So in order to satisfy what David's more needs and expectation, we design a gap analysis web page for him. So this main page provides a clear introduction and let users choose 4 key datasets, which each key dataset feature distinctive characteristics. So if, for example, if I choose the dataset 1, users can filter by sex and age. The results are shown in clean table that highlights in the 2016 gap, 2021 gap, and the gap change over time for each LGA code. So users can use the reset buttons to clear all the previous options, or choose the return to the main page to choose another dataset. So this includes identifying the LGA with the greatest improvements, which is highlighted in green, and also the most significant declines in disparities, which is highlighting in red, thereby highlighting areas in progress or concern. So last but not least, I'm gonna talk about the ERD of this subtask. So in order to, based on the subtask requirement, this is not mandatorily provided any table or entity in the hostilic ERD. So therefore, it needs to design by analytical queries and code implementations in order to filter and calculate the disparities between indigenous and non-indigenous populations across Australians LGAs for the 2016 and 2021 census. So each dataset cover each specified domains and features such as age, health, non-educations, and educations. So the shift subtask requirements involve computing the difference between indigenous and non-indigenous outcome for each year, and also the gap between 2016 and 2021 census.
Okay, let's move to my subtask. It is level 3 subtask B, like finding the similar LGA's landing page. Okay, I will walk through my persona. Her name is Sarah Whitman. She is a senior policy analyst, and we need to concentrate on her needs and goals. She needs a tool that are fast, accurate, and allow her to apply filters like census year, sex, indigenous status, and education level, especially the year 12 complexion. And she's experienced with the data, but she prefers the reconfig tools over exporting and cleaning data manually. Okay, I will. There you go. Is my web pages, and this the page closing the gap similar LGAs, and there are 4 data set. I will click on the data set 2, and here you can see the selection panels. The LGA, you can click whatever you want. I will choose Alpine. The sex is male. The year is maybe 2021 or 2016, and non-indigenous. And yeah, it must be, it's maybe the same with the persona nets. So I will choose year 12 equivalent. And there's the format. I chose the board before I click find similar LGA, means I want the users sees the format of my boards so that they can they can first understand about my web page. And the similar is not, however, it's not a error or something. So I will click it here, and there you go. It will list the most similar LGA, which is more similar to the Alpine LGA, like the with the old attributes here. And as you can see, I set it as descending similarity rate, and I count it as a percentage rate, like 99.82%, and so it's descending. Okay, so I will so I can go to, there's 3 button, like reset means you reset to the main page of this data set, and return to the main page means you can return to the similar LGA page and choose the next data set. Okay, and I will talk about the ERD model, how the ERD can satisfy my subtask. Okay, so as you can see here, I choose we start to the LGA ERD, and it connect to the indigenous space age for data set, health condition, school education, and non-school education. Fortunately, my subtask doesn't need to create more any like extra entity. It just use the 4 data set as the subtask before. So, and I use queries from the SQLite to export the data from the SQL into my web page, and filter it like when a user choose the LGA with any attributes, it have an X, and then the the queries will work as a filtering and find the most similar LGAs. So this, in the summary, my design address, Sadra needs clear filters, fast insights, and exportable results. She can copy, yes, and well, thank you for watching. Thank you for watching our web-based application. We are excited to continue developing our application and contributing to a more informed and inclusive future.